Okay, let's test what we just learned on a new setup. I'm gonna delete this sphere, which was just for demonstration purposes of the sine function. And I'm gonna create a torus. And I'm gonna dive inside and I'm gonna align it with the z-axis. Okay, let me adjust the size of this. It's a bit too big, 0.6. And let's reduce this to 0.05. Probably even more, 0.025. Yep. Next, I'm gonna increase the rows here to 16 and give it a bit more resolution here, maybe twice as much, because we're gonna want to, let me press Shift W so we can see the subdivisions. I'm gonna apply a transform, which I'm gonna be using for scaling this on this direction. Yeah. And then I'll subdivide. So we have more geometry and get smoother. Okay, this is going to be the main object that we're going to be used for sourcing. I'm also going to pull it up one so it doesn't really touch the ground. And let's animate it to rotate. Okay, we'll go here to the rotation on the z-axis and say time times 90. Okay, time times 80. So now it rotates. Probably go faster. Let's say 120. Okay, something like that. This is going to be the object that we'll use for a source. So we'll first go into another geometry and I'll call this torus source. We'll dive inside. We'll get our object merge. Let's grab the torus. Remember, you need to bring the transform into this object so that it actually rotates. And next, what we're going to do is we're going to add a bit of a mountain to this so that we can distort. Let's not center the noise. Let's just make it pull out. Adjust these dimensions, 0.2, this at 0.4. And let's make sure that this is also animated. So here I'm going to use time. Okay, so it's rotating and it's changing shape constantly. Can maybe increase the roughness here, 0.6 a bit. Now let's calculate the velocity. Let's have some velocity on this. So we'll use a trail stop. And we'll just say compute velocity. And now we should have velocity trails that take into account the rotation and also the movement that's coming from the mountain animation. Next, we're gonna transform this into a pyro source. And here we don't want to keep the input, we want a volume scatter so that we can actually scatter points inside. We will adjust the particle separation same way as before, so we don't need to worry with this for now, but let's bring it lower so we can actually see what's happening. And here on the pyro source, we want to source smoke. So it's going to be creating density and temperature. But we also want to have a volume that includes, holds the velocity information that's on these points. Okay. So for that, we will need to create an attribute transfer. And we'll transfer to these points, we'll transfer the velocity. So now if you look at these points, we should have trails on these points as well. So this will be our velocity section. Everything else is going to come from around here. So back to this pyro source. Let's go create some variation on the density with an attribute noise. Will affect both the same way. So the attribute noise will be one dimension and will affect both the temperature and the density, but for now let's just keep it on the color so that we can have a better look at what's happening. So I'll keep it animated. I'll say we'll center the noise as well. We'll reduce the pulse duration to 0.5, the element size to 0.25, and let's increase the roughness a bit as well, 0.8. And we'll establish the minimum to be 0. You can also remap it 0 to 1 so that we have 1. And we should have something like this. Okay, some interesting variation there. Now, this seems to be working well, so we'll just assign this to density and temperature. Now we'll rasterize this, volume rasterize attributes. And we want to rasterize density and temperature. We'll use the voxel size here to determine the particle separation here based relative reference. Let me bring this down as well, 0.05. This is what we have. So here we have two volumes. Temperature. So here we have two volumes, density and temperature.